Hey everyone, this is PCBC. Every time we test antennas, there's always someone who says something. Get it down to minus 10 decibels. Then someone else will say, hey, if the VSWR is less than 2, that's already pretty good. And then the newbies are left totally confused. What exactly is minus 10 decibels and what is VSWR? How are they even related? Actually, all these numbers are talking about the same thing. Today, let's clear it all up in one go. First, let's get to know today's real star, S11. It shows how much of the signal is reflected back. The signal starts from the transmitter. It goes out and heads straight for the antenna. If the match is really good, the vast majority of the energy will be transmitted out through the antenna. If the match is poor, some of the energy will turn around and come back. That's what this red part represents. S11 describes this reflection rate. Just remember one simple thing. S11 is the reflection rate of the signal. The less that comes back, the better the match. Next, the same thing goes by another name. It's called return loss. If there's one thing that's especially easy to confuse, it's this. If the instrument shows S11 equals minus 10 decibels, then the corresponding return loss is. This proves that even though dB can be negative or positive, they're describing exactly the same level of matching. So remember, for S11, the more negative it is, the better. For return loss, since it's a positive value, the higher the better. It's really the same thing. Next, let's pause for a moment and save this chart because it's a quick reference table that RF engineers often use. We can see that when S11 is minus 6 decibels, the VSWR is about 3 and the reflection coefficient is 25%. That means only 75% of the signal is transmitted and 25% is reflected back. Minus 10 decibels. The VSWR is about 1.92. The reflection coefficient is 10%. Minus 15 dB. The reflection coefficient is only 3%, and at minus 20 decibels, it's just 1%, which is really good. At minus 30 decibels, it's only 0.1%, so 99.9% of the signal is transmitted. So in the future, when you see these numbers, you can automatically convert them in your head. How much power is actually being transmitted? Here's a classic example. Suppose you transmit 100 units of power and S11 equals minus 10 decibels means, well, 90 units of power are successfully transmitted and 10 units of power are reflected back. If your transmission power is 1 watt, then that means zero point 0.1 watts of energy is coming back. A lot of people are surprised when they first learn this number, saying, so minus 10 decibels isn't actually that perfect after all. That's right, it's just the passing line in engineering, not a perfect score. So, what level is actually good enough? The answer is very much an engineering one. Wi Fi, Bluetooth. For these, we generally require minus 10 decibels, and that's already more than enough. As for GPS, many engineers hope to achieve better than minus 15 decibels. High performance communication systems have even higher requirements, aiming for minus 20 dB performance. But keep this in mind. Engineering isn't like taking a test. You don't have to get a perfect score. It's about meeting requirements in a stable and reliable way, because the better the performance you demand from this value, the higher the cost will be. Today, just remember these three things. First, S11. The lower the better, because less reflection is always better. The higher the return loss, the better, because it's just another way of expressing S11. For VSWR, the closer it is to 1, the better, because that means the match is nearly perfect. These might look like 3 different numbers, but they're really just 3 ways of telling the same story. And that story is, how well is your RF system actually matched? Thanks for watching.